Question 72. Find the area of the region bounded by the curves y1 equal to x cubed plus 2x squared and y2 equals x squared plus 2x. So I took these questions, all these questions from a textbook, which I'll leave the titles below in the description box. Okay, so we want to get the area of the region bounded by both curves. Like I said, the top curve minus the bottom curve. But since we have a negative section, which is a pink section, we need to separate this and do two different integrals. So integral of from -2 to 0 of the top, which is y2, minus y1. How do I know which one is y2 and y1? You simply look at y2, which is the quadratic and is a parabola, right? And then y1 is the cubic function. It's quite easy to identify when you know how to do functions. Okay, this would be what our integration needs to look like, the pink and the green section. So let's do y2 and y1, simplify them so that we can plug them in there. So y2 minus y1 will give us x cubed plus x squared minus 2x. y1 minus y2 will give us the reverse of that, right? So it's going to be a negative value. So I'm just going to affix a negative value to it. But keep in mind, we must take the absolute values of these functions at the end of the day. Okay, so let's plug that in, integrate them by adding 1 to the power and dividing by the new power. Going to have x to the power 4 plus x cubed, x to the power 4 over 4 plus x cubed over 3 minus x squared from -2 to 0. And then the same function from 0 to 1. The same function with slight difference of a negative, of course. Don't get me wrong. Okay, so let's plug in our values. We have the pink area and the green area. You substitute all those numbers in there. That's a lot of fractions, and I know nobody likes fractions, especially students. So when you work that out, it should give you the absolute value of -2 minus 8/3 plus absolute value of -1/4 minus 1/3 plus 1. Okay, that gives us 14 over 3 plus 5, 12. Simplifying using a common denominator should give us 101 over 12 square units. Question 73. Find the area enclosed by y equal to y minus x and y squared equal to x plus 1. Here's what the graph looks like. You can plot this using decimals, and you would see that you would need to go with respect to y from what the shaded region looks like. So you need to make x the subject of the formula in each of these cases. So for the first one, x is 1 minus y, and for the second one, x is y squared minus 1. Okay, now which one is the top, or let's say the function ahead? It's the straight line, right? So you need to take the integral of the straight line and minus the integral of the curve, which is the parabola. So that will be x1 minus x2, starting from -2 to 1 according to the graph. We plug in each of the functions, we subtract and simplify, then we calculate absolute value. Simplifying that, means we need the integral of 2 minus y minus y squared, and that will be 2y minus y squared over 2 minus y cubed over 3 from -2 to 1. Substituting 1 and -2, we should get 9 over 2. So we have the integral of a floor function, which is interesting. The floor function, the floor value of x squared. So we need to find the integral from 2 to 4. So we're going to do this visually using its graph. Okay, so if f of x is equal to x squared, What happens when x is 2? Since we're integrating from 2 to 4. When x is 2, we have 2 squared, which is 4. And the floor function of 4 will be all the numbers that are greater than 4 but not equal to, let's say, 5. So we're going to have 4.1, 4.2, because the floor values would still be 4, right? So it looks like this. That's when x equal to 2. Now, when x is equal to a 3, it's inclusive. When x is equal to a 3, we have 3 squared, which is 9. Floor value of 9 goes from all the numbers that are slightly greater than 3 but not up to 4. So 3.1 squared will give you a number that is close to 9 but not greater than 9. Then you do the same thing again. When x is equal to 4, you have f of x being equal to 16. Floor value of 16. Okay, let's say do f of x equal to 4.1 and you square it. It will still give you a function that's close to 16. So the floor function of that value would still be 16. And now you have the graph. But now remember, integration is actually the area on the graph, like combined together. So what we're going to do is calculate the area of each of these rectangles. In this case, we're going to have 4 plus 9 plus 16, which will give us 29. And that's how you can calculate this area. Question 96.